have to forgive me. I just got over a terribly bad bronchitis, incredibly bad. It's the sickest I've ever been in my life, and I'm just getting over it. So my voice is a little bit hoarse. So the underlying premise of all of my research is that there are important genetic differences between racial and ethnic groups. That is the major difference between me and folks that say there's no difference. And that point is illustrated by this slide. And this is pretty simple math. All these guys did is they screened about 300 genes, identified all the genetic variants, and all they did was catalog the distribution of these variants across racial lines. And what they showed, and I've color-coded it for convenience, is in pink, which is on the bottom, are those variants that were cosmopolitan, meaning that they were ubiquitous. Meaning if I found it in one population, I would have found that same variant in another population. So 25% of all the variants out there. But what they also found, shown in yellow, is that about 21% of the variation out there, all the misspellings, were private. Meaning that had we done the same old and studied one population, we would have missed a lot of the genetic variation that was or is relevant in other populations. So doing the same old would have precluded us from identifying a lot of variants in other populations. And as Kenny said, a lot of these variants are benign or innocuous, meaning that they don't have an effect. They're just junk. But I believe that some of these variants may help to explain differences in disease prevalence, disease severity, drug response, and some of these variants can help modify well-known genetic risk factors or attenuate the effect of genetic risk factors. And to give you an example, out of all the infighting out there, out of all the politics of science, we do agree that there are some genes for some diseases. And Alzheimer's disease has a candidate gene that if you have the E4 allele of the ApoE4 gene, your chance of getting Alzheimer's is pretty high. But what's less known, or less talked about, but well known, is that if I randomly gave out the E4 card to each of you, the strongest predictor of who's going to go on to develop Alzheimer's here is your racial background. So if you're an E4 card carrying member and you're Japanese, you're toast. The risk is high, incredibly high. If you're Caucasian, it's also incredibly high. But if you're African American, it's zero, negligible. What's interesting, though, when you look at the frequency of the E4 gene or the allele in different populations, which is shown here in yellow, it's highest in African Americans. The fascinating thing is African Americans get Alzheimer's disease at the same rate as Japanese and Caucasians. So an important question is, did we miss the Alzheimer's gene entirely in African Americans? Or is there something that's important, whether it's environmental, is it cultural, is it dietary, or is it genetic within the African American gene pool that is somehow modifying the effect of the E4 allele? So that is important because that tells me that we need to make sure that we understand what's going on in the African American population that is somehow protective. But we also need to understand what's going on in the Japanese population that's such a risk factor. Is it just genetic or is it dietary? We don't know. Do collard greens, for example, in African American populations, are they protective? Or is there something in the environment? And that's why we need to figure this out. And the folks that are saying that there are no differences, ergo, we don't need to study these populations, I think we would miss all these beautiful opportunities to better understand disease if we followed their advice. So for asthma, what I study, in the United States, the population with the highest and lowest asthma prevalence are Puerto Ricans and Mexicans. Yet the vast majority of our dollars have focused on this one population. When you look at death rates, which is the worst outcome from asthma, again, Puerto Ricans have the highest accident rates, African Americans also have the highest death rates, Mexicans have the lowest. And I readily admit that a lot of these observations are likely to be environmental, likely to be due to SES, socioeconomic status, which is like access to care, discrimination, maybe getting bad medications. But I also believe, as a physician scientist or as basic scientists, that we would be remiss in our responsibility to the public if we were to overlook the possibility that there could be important biologic differences. And to that end, we've initiated studies to look at this. But just to give you a background, you may be asking yourself, well, what's the difference between Mexicans and Puerto Ricans? They're all the same. This is actually a question that I get all the time. Well, they're not actually the same. And just to give you a little history lesson, this is the migration of Africans from Africa. Maybe not migration, the forced enslavement and transport of Africans from Africa to what we call the New World. And being in the U.S., we have a very U.S.-centric view and think that most of the slaves came to the U.S., but that's in fact wrong. And this slide kind of gives you a graphical proportion of the distribution of enslaved Africans. The vast majority went to Latin America, the vast majority. And so what makes up Hispanic populations is that they're really a tri-hybrid population, African, Native American, and European. And the resulting, or sixth, or new population is really a mix of what we call mestizos. They're mutt. And the muttedness of each individual varies, or the proportions of ancestry varies by each individual, but also each group. So to give you a flavor of this, we've used genetic markers, and I'll explain a little more about these later. But we use the genetic markers that you guys hear about on TV. They're forensic anthropologic markers. They're the markers that you hear about on CSI. I find some blood in the wall, I wipe it off, I do a genetic test, and I can say that this person is 80% likely that he's Caucasian, 20% likely that he's Asian. I get a percentage of that individual's likelihood. It's a probability. Now, there's not one marker that could tell us much, but the combination of several can give us a pretty good estimate of that person's genetic ancestry. Now, that in itself has a whole bag of stuff. But we estimated the ancestry of our Mexicans and Puerto Ricans, and the colors represent the proportion of genes that have derived from either African, Native American, or European. Yellow is European, red is Native American, green is African. And what you see is Mexicans and Puerto Ricans are derived of three ancestral populations, but the relative proportions differ, thus making them genetically distinct. But when you turn that table, that was a group admixture, when you turn that table on the side and look at individual admixture, which I have here, it's all over the map. Now, on this slide, I have Puerto Ricans on top, Mexicans on the bottom, and each bar represents an individual, and each color represents the proportion of that individual's genetic ancestry. So in this case, individual number 1 is 100% Native American. Individual 49 is like Vicente Fox, 100% European. I think I'm individual 59. And then there's individuals like Sammy Sosa. He's probably part African, part Native American, and European. The point is, in order to get into our study, at least to make it on this slide, each individual self-identified their biologic grandparents, their biologic parents, and themselves as being 100% pure, either Mexican or Puerto Rican. So the fact of the matter is, these guys don't know what they are. And this is a challenge. A couple of years ago, geneticists wouldn't touch with the 10-foot pole what we call racially admixed populations, African Americans and Latinos. And the reason was this complexity can throw off studies. So for example, what if I gathered all my asthma cases over here and compared them to healthy controls over here? And I said, aha, I found a gene that's associated with asthma. But in fact, what I really found is